Okay, class, so we're going to just quickly go and have a little look at some of the homework there. Fair play to you so far for turning it in. All right, there's one still outstanding from Monday's class, and as we go through there, there's only 2 or 3 that are yet to hand in work. All right, so if you are part of the 1, 2 or 3 there that still have to hand it in, you want to make it your business to get on it. All right, so we're just going to start and have a look at the homework there on question 1 to 7. All right, so if we have a look at our textbook, starts on page 91. Our stats 1 collecting data does. All right, so scooting on here onto the first section. So here, exercise 5.1. All right, so if we just have a look here, first of all, we're asked to basically describe whether each of the following is going to be numerical or categorical data. So is it dealing with numbers or is it dealing with categories? So the number of cars sold by a certain garage last month. So the number of something, you're counting them, then it is numerical. The favourite soccer teams of pupils in our class, well, it's teams, all right, so you're given a category of a team. Each team is a different category, so United, Liverpool, and so on. All right, so that is categorical data. The continent of birth of people who came to Ireland in the past year. Again, various different continents. It's a category, categorical data. The number of horses in a race. We're counting again. So do you remember what we were saying? Numerical and categorical. If we're counting something, numbers, numerical. The time taken by the winning horse to complete the race. Again, time. We're counting it. It's 2 minutes, 3 minutes, whatever it is. So category or numerical. The blood type of teachers in your school. Blood type A, O, B, whatever it is. Categories. Types of trees in the wood. Again, types, categories. So categorical data. And the length of time taken to complete a Sudoku puzzle. Length of time again is numerical. Question 2. State whether each of the following is an example of primary or secondary data. So remember, primary data is data you yourself collect. Secondary data is data collected by somebody else. So Connor tossed a coin 100 times and recorded the results to investigate if the coin was fair. Connor's doing it himself, so then it is primary data. Brenda counted the number of SUVs that passed the school gate between 9 a.m. and 10 a.m. She's out counting herself, so again, primary data. Turning over the page for part 3 and 4, Shane used the internet to check the number of medals Ireland won in boxing in the last Olympics. So Shane is using the internet. He's looking on the internet and he's reading off facts that somebody else has put up there. So he's using somebody else's work, so it is secondary data. Emer then checked the CSO office or website to check the number of people on the live register. Again, she's using somebody else's data, so therefore that is secondary data. Now, I'm not going to go on through do all of these, so we might skip on to 4. Niamh wants to find out how often adults go to the cinema. She uses this question on the questionnaire. How many times do you go to the cinema? Not very often, sometimes, or a lot. So write down 2 things wrong with this question and then describe a better question for her questionnaire to find out how often adults go to the cinema, and you should include some responses. So what is wrong with this? All right, how many times do you go to the cinema? First of all right, she's assuming that people in fact do go to the cinema. All right, and if we look also at the answers, not very often, sometimes, a lot. What is a lot and what is not very often? Do you know, for somebody, a lot might be 5 times a year. They say, oh, why would I want to go and see any more than 5 films in the year in the cinema? All right, that might be for them a lot. But for another person, a lot, it could be 25 films in the year. All right, so there's no way of ascertaining how many times each of these is broken into. So a better question would be, and we want to include what we're saying with our answers, all right, so you should include some responses in your boxes, right? If you go to the cinema, how often would you go, and include a time frame? per week or per month? Probably something maybe more like every month. So how often or how regular do you go to the cinema per month? Once, twice, you might include a 0 actually, and then maybe at the very upper end say 5+. All right, so then you have an exact set of data there that you can work from very accurately, whereas what's given here, it's a very open-ended, right? So it's not a clear, concise question. All right, so Niamh has to do a bit better on that one. All right, if we look down here, we'll say on to 6. So the graph on the right shows the midday temperatures for each day in July. All right, so you've got your month of July, and there are the temperatures for the middle of the day. Outline the categorical data contained in the graphic. All right, and part 2, are the dates July 1st, 2nd and 3rd numerical or categorical? All right, so just pause here and have a little think about it for yourself if you haven't done already. So we want to outline the categorical data contained in the graphic. All right, well, first of all, up here we're given the month. All right, so it's telling us it's in the month of July. All right, so that is the category, the month there. We're also then broken down into each of our individual days, and within each day they're actually given the date in July for whatever year this is. So what categorical data have you got? You have the month, you have the various days, and you also have the date. So the idea here is, if we were to look at July over the course of 10 years, well, on the 7th of July, what was the average midday temperature, over that 10-year period? So you're able to use, your kind of a long-range model there to see, well, is the month of July getting hotter? Is it getting colder? What's the story going on? So that is the kind of thing there that you're talking about. Part 2, are the dates July 1st, 2nd and 3rd numerical or categorical? All right, and explain your conclusion. So they're actually categorical, even though they contain numbers, right? July 1st, July 2nd, July 3rd, all right? But we're not doing that, we're not counting. So numerical, when we're dealing with numbers, right? July 1st is a category. It's a day in the month. July 3rd is a day in the month. It's a category within the month. So I want you to look at and visualize that we have from the 1st here to the 31st. So we have 31 categories, all right, within the month of July, and they define each day. So it's not that we're dealing with numbers. We're not counting each day as another day and getting all the way up from 1 to 0 all the way up to 31. It's a category, it's a day within the month of July. All right, so that's that one there. All right, and the last one for the first exercise there that you'd only 1 to 7 to do, was question 7. So a Premier League team has 24 first team players. Their average age is 26 years. They were born in Ireland, England, Croatia, okay, and all of those. Describe the data contained in each of these statements above. A Premier League team has 24 first team players. All right, so it is numerical data. They're telling you that there's 24 players. Okay, what else are we being given? All right, we're told then that their average age is 26 years. All right, so the age of them, all right, the average age is 26. So that's the information, that's the data that we're being given in that statement. And they were born in various different countries. So there is categorical data there for your countries. So you've numerical in terms of the number of players, you've numerical in terms of their age, and you've categorical in terms of their country of origin. And I suppose you also have a category in that they're playing for the first team and not the second team or third team or whatever like that, and that they're playing in the Premier League, if you want to be really 100% precise. Okay, so that's all for the corrections for Monday. All right, now we're going to go on to the next section here, which was 8 to, I think, was it question 14, and then we'll look at a few more. All right, so we'll skip 8 and we'll have a look at 9. Aidan wants to find out what students think about the library service at his college. Part of the questionnaire he has written is shown. What is your full name? Question mark. 2. How many times a week do you go to the library? Often, sometimes, or never. Why should question 1 not be asked? And also, what is wrong with the choices offered in question 2? So, he's asking for the name of the person. Now, when you're doing questions and surveys and all of that, it is assumed that the responses you give are anonymous. All right. So, if you want people's 100% honest opinion, you're more likely to get an honest opinion if they know their name isn't tied to what they say. All right, because for whatever reason, people may decide to change what they say if they know they're going to be identified. Similar to the question we had already, the responses here, often, sometimes, never, right? Sometimes. Is sometimes once a week? Is it 3 times a week? You know, sometimes for one person is going to be a different time for someone else, all right? Often, again, same thing. So we need to give exact figures. So do you go 0 days or times per week, twice per week, 4 times, 10 times, or 10 plus times? Something like that. All right. Question 10. This question was included in a questionnaire. How old are you? Young, middle-aged, or elderly? All right. What is wrong with the question and responses? And rewrite the question and responses in a better way. So again, same as this. What is young? All right. If you ask a 15-year-old, they'll say they're young. If you ask a 20-year-old or a 25-year-old, they're going to say that they're young. If you ask a 30-year-old, right, they're just gone 30, they're maybe not too happy, they'll try and hang on and say, oh, I'm still young, all right? But if you come along and ask a 90-year-old, and the 90-year-old is talking to a 50-year-old, well, the 90-year-old is going to refer to the 50-year-old as young. But if you talk to a 15-year-old, the 15-year-old will say the 50-year-old is old. So again, that's very open-ended. It's not precise. So we want to include exact figures or ranges more so in this case. So rewrite the question. So we could include which age category do you fall into? So 0 to 18, 18 to 30, 30 to 50, and so on. All right, so that'd be a better question there like that. We'll skip 11 there and we'll have a look maybe at 13. All right, so for each of these questions or statements, what would the best way to collect the data, and choose on the box? So questionnaire or data collection sheet, experiment, or some other source. So what's the correct best way to collect the information? What sport people in your class watch most often? Well, probably a questionnaire, all right, or a data collection sheet to tick the box, all right? That's probably the handiest there. How often people go to the theatre? On which days? So you could conduct an experiment, all right, or you could potentially just stand outside the theatre and survey people, because you want to obviously survey people who go to the theatre, so how often people go there. So it would make sense to maybe target that audience. On which days, and then give them the option to fill in the days. The percentage of motor vehicle accidents in Ireland that occur between 6 p.m. and midnight. All right. How we're going to do that? You're not going to go and collect that data, so you'll go look to another source or something that would be provided on the internet. So secondary research in terms of maybe I don't know, so the Central Statistics Office might have figures like that on that. Owen wants to find out if a dice is biased. All right, well, he would do an experiment. All right, he would experiment on the die, flipping it 100 times and recording the data, and he would hopefully expect roughly a division of 50-50. The bigger the experiment number, the more accurate your results. So if he flipped or tossed a dice, if he tossed that dice 10 times, potentially he might get, maybe 8 sixes. All right. And he might say, oh, well, I have this test done and it's coming up that it lands on 6 a lot more than any other number. Well, it's a biased dice. But if he, instead of doing 10 flips, if he'd done 1,000, he would realise his results are a lot more accurate and he would get better results there. Just checking back, where did we have to go? So we've done 8 to 14 and then 18 and 19. All right. Sorry, no. So 8 to 14. We'll have a look at 14. So a mobile phone company wants to carry out a survey. It wants to find out the distribution of age and sex of its customers and the frequency with which they use their phones. The company intends to use a questionnaire. Write 3 questions and corresponding responses that will enable the company to identify or efficiently carry out the survey. All right. What do they want to do? So they want to carry out a survey. They want to find out the distribution of age. So your first question be, which age category do you fall into? And then have your categories say 0 to 18, 18 to 30, and so on. Sex. Simple. Are you a male or female? Take the box. You can only be one or the other of its customers. And the frequency. So frequency means how often something happens. So the frequency with which they use their mobile phones. Okay. So a question there could be, what would we say, right? So assuming that everyone uses their phone every day, you could say, how often would you use your phone per day? Less than 1 hour, 1 hour to 2 hours, 2 to 3, 3 to 4, or 4 plus. All right, so something like that. But there's loads of other questions there you could ask. Some of them, there's only one, like the likes of identifying are you male or female, there's only one question there. All right, so we'll skip this on, and what do we say we had 18 and 19. Right, 18 and 19. So Susan is trying to find out the opinions about the local soccer club. She posts the question to their Facebook page. Give a reason why the data collected might be biased. So Susan is trying to find out opinions about the local soccer club. She posts a question to their Facebook page. So she's targeting people who are part of the club. The data that she gets back might be considered biased because the people that are going to be answering the questions are part of the club. All right, so they will have kind of a bit of loyalty and a bit of a bond to their club. So they're going to give very good opinions on the club, by and large. All right. Whereas if you asked an opposing club's members, what should they think of the club down the road? They say, it's rubbish. They're muck. So your target audience, you have to make sure that it is a generalization of the whole public, rather than, in this case, she's targeting people from the Facebook page of the club to figure out their opinions of it. So you're not maybe going to get your most accurate results that way. 19. Alex has decided to do a project on social media use in his class. Write a question he might use that would give numerical data. So his use or project on social media use. Okay, so a question might be, how many social media apps do you have, do you use daily? 0, 1, 2, 3, 4 plus, whatever. Or you could use, how many hours, all right, or how many minutes do you spend on social media daily? 0 to 20 minutes, 20 to 40, an hour plus, so on and so forth. All right, so that was the first and the second section of homework there. We had then having a look at question 15 and 17, and then moving on then to exercise 5.2. So if we have a look at, what did we say, 15 and to 17. So we'll go back here. So 15 to 17, right? So you can see here, we've got numbers here. So I'm just going to copy this and okay, and we'll come across here then, and now we can work with that data there then. All right. So The ages of the members of the school drama club are as follows. And there they are there. Create and complete a frequency table to display the data. So we'll start with that. So we're going to create a frequency table. So, well, what's the lowest age? Have we any 1 in 11? So I don't see any 11-year-old there. What's the highest? 17, 18. 18 is the highest. So we're going from 12-year-olds up to 18-year-olds. All right. So our frequency table here. So we're going to start here. So age is going to go in here. Our tally as we go. And our frequency. So F for frequency. So we're going to have 12-year-olds there. 13 in here. 14-year-olds. 15. 16. 17s. And 18s. All right, I'll change color there, so we'll go to green. All right, so we're going to have 12-year-olds, 13, 14s, 15s, 16, 17, and 18. Right, so how many 12-year-olds have I? All right, well, there's 1, 2, 3. So we have 3. Here's my tally. Frequency here is 3. All right, 13-year-olds. Well, we have 1, 2, 3, 4, 5, 6. So we have 6, 5 or 13-year-olds. 5 and 1 is 6. 14s. So we've got 1, 2, 3, 4, 5, 6, 7. And we have 7. So there we have 5 and 2 more. 7. All right, up to 15s now. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 9 of them. Which is 9. And we're on to 16-year-olds. So we have 1, 2, 3, 4, 5. Now you don't have to do this tally box here, but it's handy, and it's, you know, as you're going, like if you didn't want to cross them out in your book, which I wouldn't recommend crossing them out in your books, I just tally them up here. So 17-year-olds, we've 1 here, 2, 3. So we have 3 17-year-olds, and I think there's only 1 18, yeah, 1 18-year-old. All right, so frequency table, and then we want to do up our total. So 4 and 5 is 9, 9 and 9 is 18, 25, 31, 34. So we have 34 in total. So that's part 1 done, right? What is the difference in the ages between the eldest and the youngest in the club? What's the difference? Well, if 12 is your youngest, 18 is the largest or the oldest. So 18 minus 12 is 6. All right, so there's 6 years in the difference. What is the most common age? Right, remember, most common is another word for the mode. Right, well, what's the most common? What's the highest frequency in this here? Well, we've got 9 is the largest frequency, and that accounts for our 15-year-olds. So what is the most common age? Well, it is 15-year-olds. All right. What is the least common age? Well, that is the smallest frequency, which is 1, so 18 years. And then part 5, what percentage, right? Okay, remember we mightn't have looked at percentages just yet in this, but it comes up in our second chapter. What percentage of the club are seniors, i.e. 15 years and older? Correct the nearest whole number. So, this part you may not have understood. So, percentage is, we want to start with a fraction, right? So, the percentage is equal, so P for percentage, we're going to create a fraction. Well, what percentage of the club? So what percentage of the club? Well, there's a total of 34 players in the whole club. So the denominator in our fraction is going to be 34. All right. What percentage of them are seniors, i.e. 15 years and older? Well, 15 years and older. Well, we've got 9 and 5 is 14. 15, 16, 17 and 1 is 18. All right. So here we have the percentage of players that are greater than 15, or greater or equal to 15, is 18 all over 34. Correct the nearest whole number. Now, I don't have my calculator on me here, so we'll have to, I don't have my calculator, so just round that off to whatever it is. Okay, now here, I'll use actually my phone. So if we come down, alright, so that's equal to, what is it, 0.529, alright, correct the nearest whole number is 0.53, which is equal to 53%, alright. So the percentage there is 53. So the only part of that you should have had maybe an issue with was the last part, part 5, assuming that you were happy enough with making your frequency table. Okay. Having a look at the other two questions. So Angelina wants to find out what type of music the students in her year group like best, design a data collection sheet so that she could use this to collect the information. So it could be a simple case of a sheet where on the left column going down, she's all her different genres of music, all right? And along the top, so if we just have a look over here, so if we just say that she has along the side here, going across, I'm going to change into, so music types, I'm just putting types. So all your music types are going down there, so pop and all that, all they're going across. And across here would be, you might have a scale. So you might have 1, 2, 3, 4, and 5. And you might be asking people to rate each genre of music from 1 being their least favorite to 5 being their most favorite. Okay, so that could be a way that she might be able to collect that data. All right. 17. So again, we're working with the tally figures. The final round scores in the Irish Open by the top 30 leading golfers were that. Using a tally chart, make a frequency table for this data. Which was the gap between the highest and the lowest score? What was the most common score? And what percentage score scored higher than the most common? All right. So I'm not going to do that in here because that's very similar to this. If you struggled, have a look at question 15 and come back and try 17 there again. All right. So that was all exercise 5.1. 5.2 then, we had question, was it 1 to 5 or 1 to 7? 1 to 7 there. So we'll just pick 1 or 2 of them. I'm just trying to be mindful to keep this video as short as possible so that you're not going to be bored to tears with it. So say just having question 2 there. Jack wanted to find information on how much pocket money the 900 students in his school get each week. He planned to have a sample size of or 40 or 400. Which sample size should he pick, and explain why you did not choose the remaining two options? Okay. When you're conducting a survey, the greater the sample size, the more accurate the responses are going to be. So if he is sampling 400 kids out of the 900, he's almost at 50%, all right, of his survey. Okay, so the results, if he surveyed 400 people, would be very accurate. But if he's going to collect data on 400, it's a lot of work. If he was to collect 40, all right, it's a lot less work, but it's less accurate. All right, and 4, I would discredit altogether because it's way too small to be a representation of 900 students, and it's nearly not worth your while only collecting data of 4 people. So you could have said 40 or 400 for the reasons that I've just said, all right? So 40 in that it's less work, but it's not as accurate, or 400 in that it's the most accurate, but it's a lot of work. So whichever one you wanted to go for, as long as you're explaining why you did not choose. So it's your opinion. Why are you doing what you've done? Have a look at 4. Melanie wants to find out how often people go to the cinema. She gives a questionnaire to all the women leaving a cinema. Her sample is biased. Give 2 possible reasons why. First of all, she's only sampling the females, so she's not getting a gender neutral response. Secondly, she wants to find out how often people go to the cinema. But she's given people who have already gone to the cinema, they're leaving the cinema, and she's questioning them. So they are going to the cinema, all right? So where's that come from? All right, so everybody she samples goes to the cinema. So she's going to get no opinions from people who maybe don't visit the cinema that regular, all right? So her sample is biased in who she's picking for 2 reasons. She's only picking the females, and she's only sampling people who are coming out of a cinema. So they're more likely to go to the cinema than, say, somebody down the shop. Having a look at 6, Dara wants to find out how people get to work each day. Which of the following is the most appropriate group to question? So every 4th person at the bus stop, a group of people at lunch break, and people arriving late for work. So every 4th person at a bus stop? No. That's not the group to pick because they're at a bus stop, so they're going by bus. They're not going by any other method. People arriving late from work, right? Again, I wouldn't sample those people because they may all be late for a particular reason. So if they came by bus and the bus got a flat tire, all right, then you're not going to get an even representation of the workforce. A group of people at lunch break. They're all at work. They're all on their lunch, so you have a much fairer chance of getting opinions in that group compared to the other 2. All right, so that was 1 to 7. And the last section I will go through with the live in on Friday's class. Okay, so the questions 8 to 12 and also some of the test yourselves. All right, and I can see, even though it's due tomorrow, 7 of you have it already done, so fair play to you. Yeah, so we'll call it a day there, and we'll talk to you on class on Friday.